Hello guys, I hope you all are doing great. So I came up with a channel where I discussed on some certifications which I did related to network, security and cloud, and some basic concepts. I started with network. So after that, I recorded a video on basics of networking in Hindi. That's where I got a lot of comments from some of my friends saying that I need to record, or I should record, basics of networking video in English also. So it's going to be helpful for those who are preparing for any certification which is related to networking or maybe other certifications, because these concepts are very important. You know, basics of networking is needed, whether you move to security, you move to cloud, or you move to IoT, big data, how to blockchain. So basic networking, which I have seen, is needed. My name is Sheikh. I work as a corporate trainer. I have done some 20 global certifications, 20 plus related to network security and cloud, where I am discussing with all of you how it is going to be helpful. So today we are going to discuss on basics of networking. Some topics. I have already recorded some of the topics, but now I am coming up with a single video where I'll be trying to explain these basic topics related to network, security, and cloud. So I'm going to share my screen. Network basics. So let's see what we have here when it comes to network basics. Now, there are a lot of things, when it comes to network, there are a lot of things, but we would like to understand some basics. So if you want to go deep in this, I would say go for CCNA, where you can make your career in networking, and go for CCNP, CCIE. So I was a part of Networking Academy, Cisco Networking Academy as a trainer. I am EC Council certified trainer. I am also a cybercrime intervention officer, and I'm also Microsoft certified trainer. So here we discuss some important concepts, whether you do network plus, that's very deep, but sometimes you are not interested to move into networking, but you want to understand some basic networking concepts. So let's understand here what are some of the basic networking concepts. So first one is the OSI model, or what is the role of OSI model when it comes to communication. So you might have learned OSI model in your schools and college, where we understand all the 7 layers. So physical, data, network, transport, session, presentation, application. Or please do not take salesperson's advice. Please do not throw sausage pizza away. This is how you remember those layers, because whether you apply for any networking job, it is compulsory that you will be, you are being asked a question based on OSI model. So this is a reference model. Lot of reasons were there why it came. So I remember some of the most common reasons was to reduce compatibility. So everyone who is going to design a device, they will follow some standard. Or if you troubleshoot a network based on OSI model, that is what we call logical troubleshooting, right? A lot of other reasons were there. So there's also TCP model, TCP/IP model, which is implemented because it was designed by the Department of Defense. So this is how they combine those layers, made a model, but this is a reference model where there are 7 layers. So in TCP/IP, you have 4 layers. So physical, data, network, transport, session, presentation, application. So the name of data here, we call it bits. We call here frame, packets, segment, and here we call data, data, data. So now let's assume this is my computer. So on my computer, I have IP address. So let's assume this is my IP address, class C IP address. I have port address. I call this port address. These are some port numbers, source port numbers, which are generated by my computer. We'll understand ports in detail, but these ports are generated between the range 49151 till 65535. So let's assume I'm trying to connect 2 sites here. So first I'm trying to connect to Google. Okay, then I'm trying to connect to YouTube. So I try to, write in the browser. I'll open browser. I type www.google.com. So I'm interacting with application layer. When I try to open browser, when I try to write the web address to which I am trying to communicate with, this is interacting with application layer. So I am telling my computer, please get me the Google page. My computer says, I don't understand. But what my computer does, it will go to the DNS saying, Mr. DNS, Sheikh is asking me to get Google. So you know what is this? DNS says, yes, you have to get this IP. Okay, so DNS has the mapping of the domain and the IP. So my first request goes to DNS, right? Now what my computer will do, With the help of subnet mask, I assume I am using DHCP server, where it is assigning IP address automatically. I can also push a static IP, but I assume that I am using DHCP server. So I am getting IP address, subnet mask, default gateway, server, and all those settings. Now my computer will understand, okay, so my IP is 2.3. Sheikh is asking me to get 172.16.9.3. Are these two IPs in the same network or default network? So for us, we understand they're in a different network, but for computers, they will calculate that with the subnet mask. So that's why, you have a subnet mask. Now, if it's in the same network, it has to go to the switch. If it's in a different network, then give it to the router. So my computer knows that. If it's in the same network, I'll give to a switch because it might be connected here somewhere. Now it's in a different network, so it will go to the router. But how this packet is going to come, so let's understand OSI model here. So presentation layer is going to make it sure that it's going to present data in a standard format. So if I send you a file, your computer knows that it has to use PDF, or I can say to open that PDF, it has to use Acrobat Reader, or to open a Word, it has to use MS Office, because this is information which is given by the presentation layer. So on one side, presentation layer is going to communicate with the presentation layer on the other side. Session layer is going to make sessions, because see, I have two sessions. One is going with the Google, other one is going with the YouTube. So these are sessions. So it is going to give them session ID. So it differentiates between various sessions, right? So these are sessions. That's the function of session layer. But we are very much concerned about transport layer, network layer, data link layer, and physical layer. Let's see what happens. Now, when data comes down, this is known as segment. So this segment has the port information. Packet, when it comes down, it goes to a network layer. It has a, this is what we call packet. This is the IP information. And when it comes down to data link layer, it has a MAC information. So these three addresses are very important. That's why, I have three addresses. One is my MAC address, one is my IP address, and one is my port address. So that's where spoofing can happen. Now, if you try to do spoofing, you need to understand what kind of spoofing I can do. So in my computer, I can do three types of spoofing. That's why, I have three addresses. So if you see here, this is how it looks like. At outside, I have now a frame. Now physical layer is going to take this data, send it to the wire. Now this is frame. It has a MAC address, source MAC, destination MAC. So it says, I am coming from MA, right? Because this is my computer. And I am going to MD. So what happened actually? My computer knows that I have to get a router. It has the router's IP, but it needs to get the MAC address of router. So what it says, it does ARP, saying that whoever has 2.1 in this network, please give me your MAC. So this request goes to every device which is connected to switch. And router will say, oh, this is me. This is my MAC. Please send me this frame. Now router receives the frame, but router understands IP address and switch understands MAC address. So what's going to happen? Router will just open it. It will say, oh, this is coming from 2.3, that is Sheikh's PC. It needs to go to Google 9.3. Now it will check the shortest path and the best path. Routers care about the shortest path, best path. Switch care about the hosts and how they are connected. So now what's going to happen? Router will open it and it is going to create a new frame. Now it will just attach a new MAC address. Source is ME and destination is MF. So it is going to come to this because this is a Google server. On the Google, I might be running multiple services. So it needs to connect to AT because I'm using maybe HTTP protocol. If I use HTTPS, it might be connecting to 443, or there's other service running for SMTP, simple mail transfer protocol. But I need to connect to port 80. So Google is going to say, oh, this is for me. This is to this computer and it is coming to me. So with the help of MAC address, Google thinks that, router has sent it. So you will not be able to understand where from this came with the MAC address, because what happens, MAC does node to node delivery. So this is what's happening at the data layer, node to node delivery. Now this server is going to see, oh, it's going to open it. Okay, it's for me, let me open. They'll see, oh, there's a packet. It is coming from Sheikh, it's coming to 9.3, I'm 9.3. It's more for me, I can open it. If it's not for me, I'll forward it. Like the way we send a letter, I'll send it to someone in your classroom like Rick. So Rick is going to see, oh, this is for me, let me open it. If it's not for Rick, let me pass it to Rick, right? So this is what's happening, it's trust. And then this guy is saying, oh, this is coming from Sheikh, it's for me, okay, let me open. What does it have? Segment. It's saying, oh, this message is for this port, not for this port. Now this IP plus port is what we call socket. So with the help of socket, it is coming to the right computer and the right process. So I need to send it to the right computer. So IP is going to help me to send it from right source PC to destination PC. Right computer, right computer, source to destination, that is IP is going to help me with that. But port is going to make it sure that it reached to the right process. So that's what, we call it process to process communication. This is the help of segment. So when this reply comes back, now what's going to happen? MF will be the source and MD will be the destination, right? Now it is going to say, oh, let me open it. Oh, this goes for Sheikh. It will say, send a request. Now it is going to attach MD as a source and MA as a destination. But before that, it's going to send a request. I have some data for 2.3. Whoever is 2.3 in this network, please send me a MAC. I'll say, oh yeah, it is me. Let me send you my MAC. It's going to attach my MAC and send this to me, and I open it. Now this packet will come to this computer and it will come to this process. So that's where, we make use of these port numbers, right? So this is what happens, with respect to OSI model, the communication, and this is at the back end. Now IP addresses. So if we see the classes of IP addresses, we have 5 classes: class A, class B, class C, D, and E. So you need to remember, because for any exam or if you apply for an interview, they might be asking questions related to OSI model or IPv4 or whatever topics I am going to include in this session. So these are the questions they ask. So for class A, 0 to 127, in some books you might find 1 till 126, but this is the default range, because 0, we don't, it doesn't have any value. We don't use that IP address. But it's a default, sometimes, and 127 is a loop back. So that's why, they say 1 till 126, but you can go 0 till 127. 128, 191 is class B, 192, 223. And then for this is multicast, this is research and, development. So you need to remember these 3 classes. How they get it? With the help of priority bit. So every class is a priority bit. It has 0, 10, 110, 1110, 1111. So what will happen is going to replace those numbers, and then getting that range. There's a process for that. Now this is another important formula. Class A has a formula N H H H. So N means 8 network bits, and these are 24 host bits. Why? Because if you see class C, it will be 192.168.2.3. So every is here, every block is an octet, 8 bits, because 2 to the power 8 gives you 256, but we start with 0. That's the reason you have 255, the highest number. You might have never seen any number bigger than 255. Now, why there were classes, or why you need to remember, I'm going to discuss it shortly, but here you have 16 network bits and 16 host bits. Here you have 24 network bits and 8 host bits. Now, why they were divided into classes? Based on your requirement. So if you need a class C IP address, you will have somewhere 254 hosts. So in one network, you will have 254 hosts. If you take a class B, you will have 254 into 254. Here you will have 254 into 254 into 254. So depending on your requirement, how many classes or how many IPs you need in a network. So if you need like 250 computers in a network, go for class C, because it's easy. That's why, most of the times you will see class C. If you need more than that, go for class B, because for future, you have that if you have a need like this. So that's why it was divided based on, what you need. And range. So there are 2 types of addresses. One is public and one is private. So public is like your voter, is like your passport. It will be accepted everywhere. But private range is like, private IP is like your company ID. It will be accepted only within your organization. So private IPs are not payable. I mean, you're not paying for it. It's free. If I use one IP in my network, you can use same IP in your network. So you're not paying. So it has to be unique within a network. So I cannot use same IP within my network. It has to be unique within a network. And you're not paying. It's free. It was to save, IPv4 is limited to the power 32. That's the range. So it is limited. To save that, we have the concept of, dividing that into private range. So this is the private range in class A. So if you see 10 dot anything, it is private. Now, other range, in this 0 to 127, if you see anything else like, 11 dot something, it is public. Only 10 dot something is private. In class B, you have 172, 116, dot this dot anything. I can say 0 till 25. Anything means 0 till 25. I represent that with star. So it goes 0 0 255 255. So in class B, you have to check two things. For example, if I say 172.17.4.9, so you will check 172. Yes, this is 172. Okay. What about the second one? So second one should be 16 till 31. Is it 16 till 31? Yes, it falls in this range. Now, if I say 172.13.4.9, this is public. Why? Because it is not falling in the range. It is before 16, right? 13 is before 16. No, they will ask you, in class B, you will see a lot of questions, asking you, is it private or public? Because here there's a little bit confusion. In class C, if you see 192.168. anything is a private. Rest, everything is public. So which class, they will ask you, which class is this? Is this class A, B, or C? Same network or different network, or is it private or public? So how to check same network or different network? For example, I will give you 172.4.9.3, 172.4.3.9. So are they in a same network or different? You have to check first which class. So it is 172. So 172 is here. So it is class B. So what is the formula for a class B? Just write this formula: network, host, host. So what does that mean? That means these two have to match. So network, first this should match. Does it match? Yes. This should match. Does it match? Yes. So they're in same network. So if I give other example here, let's say 16.4.9.5, 17.2.3.9. So what is this? This is between, this falls in this range. So this falls in which range? It's a class A. Okay, what's the formula for class A? Just write this formula: network, host, host, host. So that means first one should match. This and this, does it match? No. So they are in a different network. So this is how you calculate, like same network or different network. Now subnetting. Subnetting is very interesting topic. There are a lot of ways to do subnetting, but I'll just give you an example. This is my class C IP. And what is the default mask? 255.255.255.0. So first what I need to convert that decimal into ones. So 255 is 1111, all ones, right? So that's why, we have 255.255.255.0. So how to calculate? If you want, you can just write a number like, 10101011. So 1, 2, 4, 8, 16, 32, 64, 128. And wherever you see 1, you have to add those numbers. For example, I see here 1, so I'm going to add 1 plus. Here also I'm see 2, so here I'm not taking 4, it's a 0. I'm again adding 8, it's a 1. 16 is 0, 32 is 1. This is again 0, this is 1. So whatever number I get, this is the decimal equivalent. So that's how I got. All ones means 255. This is the highest number. Now subnetting means how many zeros you are converting. So here I have 8 bits. So I am just converting 2. Now I am left with 6. So I will just define, this is my network bit is 2 and host bit is 6, 1, 2, 3, because total is 8. Now what I do is I'll convert that. This is now, what is this? Now this is 1, 1, 1, 2, 3, 4, 5, 6. 1, 2, 4, 8, 16, 32, 64, 128. So 64 plus 128 is my 192. So that is what I call customized subnet mask. Now it is not a default subnet mask. This was this default subnet mask. Now I need to convert it based on my requirement. So if I say, Rick, you have to make 10 networks. So your requirement is 10 networks. So you will do 2 raised power something should be greater than this 10. So you'll do 2 to the power 4, or let's say 2 to the power 3, 2 to the 4 are 8. So is it greater than 10? No, 8 is not greater than 10. Then you go 2 for 4, 2 to the 4 are 8 or 16 is greater than 10, right? So that means you have to convert 4 ones. So now here, what was my requirement? 2 to the power network bit. So 2 to the power 2, that is 4. So I will get 4 networks because I'm converting only 2. And how many subnets per network? 2 to the power host bit. So what is host bit? 6. Minus 2, 1 for broadcast ID and 1 for network ID. We'll discuss that. So 2 to the power 6 is 2 to the 4 are 8, 16, 32, 64 minus 2 is. So I will get 4 networks. In each network, I will get 60 hosts. Now I have to get a block size. How to get? 256 minus this number gives you a block size, 64. So you start with 0, you go plus 64, plus 64, plus 64, you go till 256, right? So This starts with 0. This is going to start with 64. So that means other is going to end 63. Then only you have 64. So 0, 63, then you have 64. And here it is 128. So the last one should be 127, one less than the previous one. So here it's 192. It has to be 191. So there's a mistake, right? This has to be 0. Now, 190, okay, you are not taking this because it's the last one, because you have to go till 256. It starts with 0. The first one is 1. And last is 63. So 1 before that is 62. So 1 till 62 means you have 62 hosts in this network. So how many networks? 1, 2, 3, 4. And how to assign it or how to get it? For example, if I take this example right now, let me show you, how this looks like. So this is 192.168.3.0, right? I'm writing the last number here with 0. Then the first would be 192.168.3.1. It will go till how much? 192.168.3.62, 192.168.3.63, the last one, correct? So what are these numbers? This is your network ID. This is your broadcast ID. And these numbers you can assign to your PCs. So what is the network ID? If I need to send a message to any device in the network, I will send it to this network ID, which represents a particular network. Similar to that, what is the broadcast ID? If I need to send a message to all these 60 hosts, I can send a message to my broadcast ID. So it's going to send it to all the computers. So this is subnetting. Start with class C and then you go for class B and A. So MAC address is very important. We already discussed about MAC address. So it is 48 bits. So this one here is 4 plus 4, right? This is 8, 8, 8, 8, 8, 8. So 8 into 6, 48. So this part is what we call OUI, organizational unique identifier, and this is universal admin address. So what is this OUI? This will be unique to a particular organization. So if Cisco designs this MAC address, so these numbers will be unique to Cisco. So that is how you will be able to understand who designed this. So if you go to this site, macaddress.io, and then type your MAC address, you will come to know who designed this. To get the MAC address, you can just type ipconfig all or get MAC, and you'll be able to see the MAC address, hexadecimal, 48-bit hexadecimal. So hexadecimal starts with 0 till 9, and then 10, 11, 12, 13, 14, 15, right? 9, 10, 11, 12, 13, 14. Okay, this will be A, B, C, D, E, F, right? It goes till F. So 0 to 9, A to F. You will see these numbers only. 10 will be represented by A and all that. So this is the first part, OUI. This is the second part. And, in the first part also, you have some other numbers. But this is, it to remember about MAC address. Similar to that, we have a DHCP, which is Dynamic Host Configuration Protocol. So we already discussed, if you want your computer to get this IP automatically, you can use DHCP, Dynamic Host Configuration Protocol. This is my PC. When it starts, it is going to send a first message, DHCP discovery. So it is going to discover whoever is server in this network, please give me IP address, default network, subnet mask, and all, default gateway, subnet mask, and all that. I need to go online. So this is the first message. It goes as a broadcast to everyone. So this guy, he receives this message. This guy also receives the message. Now, what's going to happen? So the guy, or the server, which is nearest one, he's going to reply. This guy might also reply. But what happens here? I'm getting a reply from the server saying that, okay, Sheikh, I'll give you an offer. Okay, so this is DHCP offer, which is coming to me. It's a Unicast message. It comes from this nearest server. So I'm getting an offer. Then what I will do, I will send a third message. So third message is going from me. It is also going as a broadcast. So where is the third message here? It goes as a request. It goes to this guy also. It goes to everyone saying that request. Okay, Mr. Server 1, I accept your request. This message goes to this server also saying that I already got a settings from someone, so you don't need to worry. You can just come out of picture because I don't want duplicate address. Simply, I'm just explaining in simple terms. So this server comes out of picture. So what happens here? Now this server will give me all this offer, then I can just acknowledge. Okay, the fourth message. This is Unicast, as an acknowledgement. So this is discovery. This is, this is broadcast, Unicast, broadcast, Unicast. Now, this server will have a pool. In the pool, it will have some range of IPs, like 40 IPs. And it is going to give me one IP on lease. Like, it will remember that I have given an IP like 3.5 or 3.8 to Sheikh on lease. Normally 7 to 8 days, you can change that also. So after 4 days, once half the lease is going to expire, my computer will again ask for the same. And if the server has the same IP, it will give me, or if it's a different IP, it will give me different IP. So what is going to happen? Sometimes, they do the DHCP starvation attack, where they will generate some fake requests, attackers, to make this server, give all the IPs, and then they will start the fake server. DNS is very important service. So it does the domain name, mapping with domain name with IP. So how it does this, we have already seen that, but let's assume, I'm telling my computer www.example.com. What is the IP address of example.com? So it goes to a local DNS server. Okay, now it says, it sends a request to the root server, because at the end there's a root which we don't write. It's a dot. There are like 13 servers around the world. Earlier, this was managed by only one person. He used to update the copy. All the admins needed to, get updated. Earlier, it used to happen like that. But after that, we have these servers, a lot of servers, because we know how important this service is. So it sends a request to the root server. Hey, Mr. Root server, what's the IP address of this? Root server says, I don't know, but com server knows, because it's a .com. So the request goes here. This is, my local DNS server. What is the IP address of example.com? It says, I don't know, but example.com knows. Then the request goes to example.com, because, it is just going to resolve that based on a dot. Then you have com, you have example. It says, yes, the IP address is this. Then I'm going to store that in cache. So if I can just, maintain that cache, let's assume, 8 minutes. So within those 8 minutes, if someone else is requesting for same page, I don't need to do all this process, because I will say, okay, someone already got that. I have that in my cache. So please take it. And, you can see these root servers here from this website. You can browse it. Why we need a hub, modem, switch, or router? See, modem is modulation, demodulation. So if you have a signal coming from any line, that's an analog signal, and it goes to a computer which understands digital signal. So you need a device which is going to convert that analog to digital and digital to analog. That's why you need modem. But why you need a hub or switch? So hub we were using earlier, it was replaced with switch. But why hub or switch? Let's assume this is my computer A, B, C, and D. Okay, so if I need to connect them together without hub or switch, so how many cables do I need? 1, 2, 3, 4, 5, 6. So if I have, let's assume 6 computers, so I need use n into n minus 1 divided by 2. N is the number of computers, so 6 into 5 divided by 2. 2 3s are 6, so 15 cables. Now you can understand how much infrastructure, and you're connecting these computers, like it will be so messy. And you need NIC card. Here I need 3 NIC cards. 1, 2, 3. So how many total? 3, 3, 3, 3, 12 NIC cards. So what I do, I replace that with a switch now, or a hub. Let's understand first hub. So how many cables I need? 1 goes here, 1 goes here, 1 goes here, 1 goes here. 4 NICs and 4 cables. So this is for ease of management. Now, why hub? Why it got replaced with switch? Let's understand that. So if I needed to send a message from A to B, A to C, the message goes to hub. Hub will say, whoever is C in this network, there's a message for you. It goes to this guy. Are you C? Are you C? Are you C? Yes. Then C sends the reply. Okay, please send it to A, B. It'll say, are you B? Are you B? Are you B? Every time. It will not understand that. So we got this replaced with switch. What switch is going to do? First, switch is going to tell, whoever is C. After that, it's going to make a table. So let's understand this table is what we call MAC or CAM table. So it will have these entries, like, it will just remember, okay, computer A is connected on port 1. Let's say, this is 1. Computer B is connected on port 2. C is connected on 3. D is connected on 4. So it will just make a table. So first time when I send a request, it will just, check who is C, like hub. But after it makes this table, I'll say there's a request going to C. It goes to switch. Switch will check the table. Okay, where is C? It's connected to 3. So it will send direct. It will not ask these guys who is this C and all that. So that's where we have such a lot of other benefits are there. Hub is a dumb device and all, but I'm just I'm trying to show you some basic concept, why we have these devices. And routers connect 2 different networks. So if you have 2 different networks, like in my scenario, first one, OSI model, we have to communicate between 2 different networks. So one was in one network and my PC was in other network and Google was in other network. If you need to connect 2 different networks, you need a router. So that is why you need devices. These are some important port numbers. So 0 till 123, these are well-known ports. They're given to some well-known applications. 1024 till 49151 is registered. You can use them, but you have to register like 3389 for RDP, which is registered by Microsoft, or this range, which is generated as a source port in previous scenario which we discussed. So 20 is for FTP, file transfer protocol. And if you want a secure shell SSH where you try to send those messages encrypted, you can use 22 port. For telnet, where you are trying to communicate with your, let's assume a server, you're sitting somewhere connecting with the server on telnet, you'll say telnet space the IP. So this is port 23. SMTP for sending mail. DNS we have discussed. Domain name system, you have port 53. DHCP use 2 ports, 67, 68. TFTP is trivial file transfer protocol. It is a type of FTP, but it is very simple. Most times if you see Cisco use it to store the operating system iOS. HTTP to get the HTML documents, port 80. Secure version use port 443, TLS SSL. POP is for receiving the mail, or IMAP 143 for IMAP, and POP is 110. SNMP is simple network management protocol to manage those devices, 161. And RTP, real-time transfer protocol for VoIP and all those calls. So these are important ports. Networking protocols. So there are a lot of protocols. These are rules. These are guidelines. We need to understand, these. So the way, if I need to communicate with anyone, so I'll say, good morning. What's your name? Or, if I directly go to someone saying like, what's your name? Or maybe, it doesn't like good. So I'll say first, good morning. My name is Sheikh. So may I have your name? So we have some rules. Similar that these devices in networking, they have some rules like TCP, transmission control protocol, or UDP, user datagram protocol. So TCP, where I need to set up a connection with the server, so it's going to send acknowledgement. So if you have any document which is very important, you do not want anything to miss out, use TCP. But if you want a speed, like you have videos, you want to buffer videos, even if there's a little bit image is going to lose because video is made of image. If there's a little bit loss in image, it doesn't matter, but speed should be good. So depending on what's your need, you can use TCP or UDP. Or POP, post office protocol for receiving mails. IMAP, internet message access protocol. This is also for receiving mail, but here you can decide what are the mails you want to download, or you can have more filters with IMAP. SMTP for simple mail transfer protocol. This is for sending your mail. FTP, we have seen file transfer protocol. If you have an FTP server, you can also use Gmail, but that will go through internet. So FTP might be secure. There is a secure version, but FTP is within your organization where you want your employees to download some files. HTTP is hypertext transfer protocol for HTML documents. This is the secure version, which is SSL or TLS. So here we trust a server because it's going to give me a certificate which is signed by certificate authority. That's why connection is secure. So most of these banking websites, they are secure. Telnet is if you want to connect terminal emulation, if you want to connect to your server using this connection, or SSH is the secure one. ARP is address resolution protocol that does the mapping of MAC and IP, which we discussed in OSI model. DHCP also dynamic host configuration protocol to allot IP address automatically. This is session initiation protocol for VoIP. It uses this. This is for simple network management protocol. We have already seen this also to manage all the devices. What is the health of these devices? So as a manager, there are some agents. Manager will try to send some request to agents saying how you are doing, or agents are going to send, we're doing final traps and all that. This is trial file transfer protocol. Simple version of FTP or DNS. We have already seen that domain name system. This is the reverse of ARP. So ARP says, I know your IP, give me your MAC. But RARP says, I know your MAC, give me your IP. Reverse. Sometimes you might be knowing the MAC, you want to get IP. IP is the internet protocol, 32-bit version. For IPv4 or IPv6 is 198. So this is IEEE 802.3 for Ethernet. So why they gave this name? Because it happened in 1980. Second is FAB. And third is the submitting. So this is for Ethernet, standard, how Ethernet should be designed, those cables, switch, how it should be designed. Or this for wireless. MAC is media access control, which we already seen, MAC address. This is the secure version. This is also secure version for FTP. So this uses SSH. This uses TLS or SSL. This is more secure. ICMP, when you use ping to check the connectivity of a device, so it is going to send, whether I'm doing fine or not with the error message if there's any problem. TLS is, those certificates, HTTPS used it to make it sure that connection is secure. SSL was the earlier version and the latest is TLS. NAT is network address translation. This also does a map between your public IP and private IP. So this was also designed to, because IPv4 is limited. So this was designed to make it sure that we do mapping. So we save some addresses, because we take one public and we are going to map a lot of private IP. So we do not need to give public IP to all the devices, because these addresses are limited. And this is carrier sense multiple access collision detection. This is a protocol which we had for hub network, because in hub all the devices will be sharing media, and when they try to send a data, they have to hear if media is free, because only one device can send at a time. Sometimes there will be a collision where two devices trying to send at the same time. So how to handle that collision? Or IPsec, this is for IPv4 is optional, but for IPv6 it's mandatory, because it's going to make it sure that all those packets are secured. So if you try to send packet from source computer destination, like in the VPN, you can use IPsec tunnel. Now devices, we have a lot of devices. So repeater, these are networking devices. Repeater is there to repeat your signal. So if you say something, signal strength is going to decrease, so it's going to repeat that. So it can move further. Amplifier is going to amplify. Repeater is going to repeat that. Hub is what we call multi-port repeater. We have already seen that to connect those devices together. Switch is being used nowadays to connect those hosts or PCs together. It's hub is being replaced with switch. Router is to connect two different networks. Modem is for modulation, demodulation. NIC is a NIC card. Every computer has a NIC card, because earlier it was an option whether you want to connect your computer to the network, but now it is mandatory. You have to connect your computer to the network. So that's why nowadays you have this card inbuilt, but earlier it was an option. That's why it was being named as NIC card, Ethernet adapter, LAN card, network card. It is for wired, also for wireless. And gateway. So we call router also as a gateway. Technically, gateway connects two different protocols. So if you have two different media which understand two different protocols, you need a gateway. Like router is our default gateway. So sometimes router will have the default function. It acts as a gateway. If you have a bigger network, you may need a separate gateway. Or bridge. Bridge, what happened? Those switch got replaced with bridge, and hub is a multi-port repeater, or hub got replaced with switch. Nowadays we have also different devices here, like router. So bridge plus router. Router has that functionality. Or bridge is going to make it sure that it is acting as a bridge. So if computer A wants to communicate with computer B, or you have some computers here, so I want to talk to you. So what bridge is going to do? Bridge is going to see, okay, Sheikh is trying to connect with computer this, so it is not here, it's on this side, let me send it back. It does not need to cross bridge. Sheikh wants to connect to this computer, so let me send it here. So bridge is going to see whether computer is on this side or this side, but it got replaced with switch. Now switch has bridging functionality. SOHO router is very important. Single small office, home office. Now what happens? You have a small network. You need modem, router, switch, and all those things. So a lot of ISPs nowadays, they design a SOHO router. So it has all the functionality. So if I see here, this is a device I got from my ISP. So I have a connection. I have a on off button. I have a reset button, or this is reset button. I have on off button. This is a connection coming from ISP. And then I have console port where I can connect and monitor this, and I can connect these Ethernet cables. I can connect 4 computers. I can connect a switch and connect other computers. I can also have an access point here, so I can connect wireless devices. So this has also NAT inside. This has firewall inside. This has parental control. It's all in one device if it's a small network, because you don't need to buy all these devices. You need modem, so it has a modem. You need switch, it has a switch. You need router, it has a router. So everything is inbuilt. So this is small office, home office router. It's good for small network because one device doing all the functionality, but if it's a big network, you need these separate devices. Now, why I am showing these 3 things? Because they do mapping. ARP does the mapping of your IP and MAC. If you remember the first diagram which we had, that OSI model. So it says, router says that, so there's a request coming from my PC to switch saying that I know whoever is router, I know router's IP, give me a MAC. So that's ARP. And DNS, the first request, I need the IP of this site, please give me. So that's what domain to IP. NAT is private to public IP, to save those IP. So these 3 does the mapping. That's why I have them in the same picture. So, you're going to kind of connect. If someone says what is ARP, what is DNS, what's NAT, all of them do mapping, but ARP does a mapping of IP to MAC. DNS does mapping of domain name to IP. NAT does the mapping of private to public IP. Now some commands like, ipconfig, ping, traceroute, nslookup. So I'm going to show you, these commands, and let me show you these commands in my network. So I'm just going to open a command prompt here. So we're just going to test these commands. So I'm just going to open my command prompt, run as admin, because as some network basics, we need to understand these basic commands. There are a lot of other commands also, but let's understand these basic commands. So I'm just going to make it a little bigger. And the first command which we had, let me see what was the first, is ipconfig. So this is to check IP address, ipconfig. So I'm getting a lot of IPs, but I know I'm connected with a wireless. So this is media disconnected. This is not the one. Sometimes we get confused what is the real, but this is the real, wireless LAN Wi-Fi. This is my IP. This is my default gateway. Okay, this is my subnet mask. This is my IPv6 link local. So I need to get other details. /all ipconfig /all. Okay, so sorry that command was not visible. So let me show you the command which I did here. Okay, Wi-Fi, or let me write it again. So this is the command ipconfig /all. When I press enter, it gives me all the details. So this is Wi-Fi. This is my description of the adapter. This is my physical this MAC. This is DHCP enable. So this is my link local. This is IPv4. I got it on lease. DHCP server is on. This is the default gateway. So I'm just sharing you all this information. Now, sometimes if I need to check the ping, like, let me ping my default gateway. So first I can just ping my loopback 127.0.0.1 to see if my NIC card is working fine. I'll just ping. So what it says, because I did double ping, so it says that Sheikh, you're typing ping twice. I don't understand what this is. So I'm sending a request to my NIC to see if it's working. 4 packets sent, 4 received, loss is 0. I'm good. Let me ping my default gateway 192.168.1.1. Okay. So if this is also fine, first you need to ping loopback, then ping your default gateway. If this is also fine, third thing is that you need to ping some site. Okay, so let me just do Control-C and just ping. Okay, let's see here. Okay, let's do ping 4.2.2.2. So DNS, universal DNS. So for Google, just try to ping this. Okay, so what happened? Pinging. Okay, it's just pinging. Okay, it's just pinging here, right? So everything is fine. Or 8.8.8. Ping for this, right? Control-C, or you can just Control-C, Control-C, Control. Okay, or you can just ping. It's a little bit slow, not sure why. Let's. Okay, it was writing here. I think I need to move a little bit down. Okay. Okay. So now CLS. Okay. Now you just ping Google. So if you are getting a reply from, if you are getting a reply from IP, but not from the domain name, there's a DNS problem which you can fix. And traceroute. Sometimes you need to, check a traceroute between you and Google. So to check the route between you and Google, you can just type this and see the route. How many routers are in between you and Google? It's going to, help you find all the routes. Or you can do path ping also. So path ping, PATH, ping ING. So you'll be getting the path here. It doesn't give you all the details, but it will just simply give you all the hops. It is just trying a maximum of 30 hops. It says, Sheikh, I'm going through 30 routers if you want to understand. And it will give me what are the 30 hops. If you want a little bit, simple, then traceroute, you go for path ping, and it's just going to give you everything. I'm just doing Control-C here. And what else? So NSLOOKUP is related to name server. So you want to see what's the name server? You just go NSLOOKUP and type www.google.com. So what is the name server for google.com? You'll be getting the reply. So this is name server. So it does the naming and all that. There are a lot of other commands, but these are some basic commands, which we just got started with. All right. So this is it about the basics of networking. So we have already discussed, that in Hindi in one of my previous videos, but I just recorded this basics of networking. Now, there are a lot of things, which you got related to networking. But this is it about basics, because I have seen a lot of, interviews. I work as a trainer, cybersecurity trainer. I started my job in networking, troubleshooting AT&T networks. I worked with a university as an assistant professor where I used to teach computer networking, and then I deliver a lot of trainings like networking. So I have also conducted some interviews where I see, these are the questions they ask. So if you go through this, I think anyone, whatever expert level they have, I don't think they will be going very deep unless and until you're going for second or third level. If you're going for level 1 as a support engineer or networking job, so this is basic. And if you want to go for some other certifications, so this is it about networking. So I don't want this video to go bigger because I've already tried to include everything, whatever is possible. So if you feel I have just missed any of the basic concepts, do let me know. I'll make a video on this. But that is it about basics of networking in English. I'll see you in some other video. Thank you very much.